Hello, my name is Sofia Vignolo, and today I will be presenting my final project for CSCI E90. The objective of my final project was to create a user-friendly and secure way for non-coding researchers to view data. This is particularly important for my current job since I have to generate a lot of analytical outputs that I then have to share with collaborators, and it is difficult to keep track of the most updated version of these outputs. And if a certain collaborator wants to see the data in a certain way, for example, if you have a plot, if you the colors to be this way or the x-axis to be in this format, generating all these different analytical outputs takes a lot of time from me. So I wanted to create a centralized platform where I can have the most updated data and give that user some freedom to, play around with the data, to view it however they want to view it, while having the most updated version. But the limitation is that they're not able to code, so it must be user-friendly. And because of this, I decided to make a Shiny app by our studio and launch it on an EC2. The reason why the EC2 is very important is because that is what provides the security aspect of it. I want to make a Shiny app, which in essence is a very user-friendly way to show data, but I don't want to share this data with the rest of the world. I only want to share it with a selected group of collaborators. And with their IP addresses, I'm able to add them to the security group of this instance, so only they're able to access the information in this instance, and then launch that Shiny app on the instance. Today I'll be going over an overview of my project in a little bit more details on how I created this Shiny app and launched the EC2, attached an elastic IP address, connected to the server and installed all the necessary packages, and then launched this Shiny application. And the overview of this project is that the app is developed on a local machine. It is tested and previewed to make sure it looks as desired, and that is done all on our studio on the local machine. Then that application is put on an EC2. The EC2, I have to install certain packages, install RBase and different kinds of things, set it up, put the Shiny app on there, and once it looks good to go, I am able to share that link with the collaborators and add the IP addresses to the security group, and then they're able to access it. And if there's ever any feedback, I'm able to update the app. For example, if I need to remove a certain output or add a new one or update anything, I'm able to go back to my local machine and edit it on our studio, re-upload it on the Shiny app, remove the old one, and the link will not change because I'm going to attach an elastic IP to it. And that way the data is always the most updated on that Shiny app. And to show you guys a bit of a more live demo, I wanted to walk you guys through how I created the Shiny app. There are two scripts that are used for this application. One is the server script and the other one's the UI. The UI stands for user interface, and this kind of details the framework of how the Shiny app will look. So if you want certain panels, how you want them, and there's a lot of functions that exist inside the Shiny package that you can use. For this particular app, I decided to make very simple, just showing different distributions using an inputted value for the number of observations, and then I use our functions to generate these distributions. So I wanted the user to select from given options using radio buttons that distribution type. So I gave them three options: normal, log normal, and exponential. This is just to give it a bit more spacing between the two options. And then I have here a slider that ranges from 1 to 1000. The initial value is set at 500. This is just arbitrary. Then the interval is of 1. That way that user can use that slider to select which value they want. And then the output is going to be 3 different tabs. One will show the plot, another one a summary table, and the other one a table of the raw data. So again, here it shows you the framework of how it will look, but there's no actual data in here, which is actually in the server script. And these two scripts kind of talk to each other in order to run that application. And as you can see, this is all done in my local RStudio. For the server aspect, I have here, depending on the input, different functions that I am running, like the rnorm, the log normal, and the exponential. And you can see here that these are functions by R that are able to generate random numbers, giving an input, an n of observation. And depending on what was inputted by the user, a histogram is generated. This if loop over here is used to, depending on what was inputted, to select the title of that histogram. And n is also going to be coming from the slider. This is going to be in the X label. All of this is going to be in the tab that is for the plot. So it's going to be a histogram. The summary tab will have a summary table. That's also, these are all functions from R that provides some statistical values like the minimum, the maximum, the median, stuff like that of that data set that was produced. And then the table is just showing the raw data. And you can actually run this on your local RStudio to see how it will look before you put it on the EC2. And as you can see, the initial value is 500 and the default of the first one is going to be normal. But the radio buttons, you can choose which one you want to see and the plot will change. If you increase the number of observations, that will change as well. Notice that the title changes as I change the distribution type. That came from the if loop. And as I change the number of observations, that X label also changes, which was put in the histogram. That's all going to be over here. So the X label changes, so does the main title because of this if loop. And yeah, over here you see the summary tab. Like I mentioned, you have some basic statistical variables like the minimum, maximum, mean, median, first quartile, and third quartile of that distribution that you see over here. And then the table is going to show you the raw data. So if I put an observation of a number of observations of 500, there'll be 500 random variables. If I change this all the way to 1, there'll only be 1. And that makes sense if the plot is just 1. If you include a bit more, that will change. And every time, even if you put the same number, the plot and the table and all the numbers are different because it's randomly generated. Now comes the interesting part. I want to share this information with a certain group of people. How do I do that? That's when you go onto Amazon Web Services. Through my Amazon Web Services Management console, I'm able to use the EC2 service to launch an instance. This instance that I launched over here is an Ubuntu instance. I use a T2 micro type just because the app is very simple and it does not require a lot of data, but if one is working with a big data set, then maybe a larger instance with more types will be needed. The security groups is an important aspect of it. I have my personal IP addresses to be able to SSH into the device. This is how I'm able to install packages and the Shiny app itself. I'm able to SSH into the instance via my terminal. And the snips of code that I used were chmod and SSH. And that's how I access the actual instance, and from there I'm able to install RBase and necessary packages that I need in order to run the Shiny app. And then I have a custom TCP rule to open up port 3838. Right now I have it open up to everyone, but ideally this would only be the list of collaborators that I want to see that data. Right now I have it open up to everyone so that the TAs are able to see it. And I also use the elastic IP addresses to allocate and associate an IP address with my instance. And as you can see, this IP address is the same as the one in my instance. And if I'm going to ever start and stop this instance, that IP address won't change. And that's important because I want to send my collaborators one link, and I don't want this link to change, because then I'll have to send more updated links and have them email me saying, oh, the link you sent me is not working. So it's to avoid some drama, the elastic IP address comes to save the day. And to see how that is launched on the EC2, as you can see here, I have my instance connected to port 3838, and I have my Shiny app. And you can see it works how it did on my local RStudio. And if you refresh it, you always get that initial value of normal and 500, but you can change that. And this is really important because if you ever want to, add more plots or anything like that, or change any output, you're able to change it behind the scenes. The link always stays the same, and the collaborators always have the most updated data. And to show you guys how I use this for my job, I actually have a Shiny app generated. It's a bit more less simple than the one I have here shown in the project, but I have different clinical data being shown over here, and it's also interactive. So if you hover your mouse over it, you're able to see, different information. And I was able to put notes in the bottom. It's also very interactive. For example, if you want, you can really, the options are limitless. You can generate anything, and you can make it very user-friendly. So I feel like I have the option to view what I want. If I want to view the data for only one subject, I can put in the subject number here and see the data for that subject. But if I want to see the data for everything, for example, I'm able to do so, or separate it by sex. And then if I want to change the colors, I want it actually by sex, and only the females will be one color, the males will be the other color. If I want to change it by the batch that they were run in to see if there's any differences. The shape will be, if it's a triangle or a circle, I can do that as well. So I'm able to generate outputs even though I don't, let's say if that collaborator doesn't have any coding experience. It's very, very user friendly. And if you want to see, for example, who this one subject is, you can click, and then nearby points will pop up over here. So it gives you a bit of more insight as to what you're viewing. And you can really generate anything. This is a spaghetti plot. We also have some dot plots. Kind of want to show a little bit more data. Some dot plots and scatter plots, all of the sort. So again, the options are limitless to what you can do. You can do something very, very simple or something more complex. But here you can really use this as needed. Thank you so much for listening to my presentation, and please let me know if you have any questions on how I may answer these.